Yes, thank you very much for the warm introduction. It's true that traditionally graphenes are very difficult. That's something that we actually want to change. So in the next few minutes, I will talk a little bit about Sixonia and our graphene, which is eGraphene and not just regular graphene, and which we would like to see in the future as a novel conductive additive for European batteries. Um, so the question, I guess, that people ask themselves when they're making batteries, especially also facing the competition from Asia and supply chains and things like this, is how can we make not only batteries like the people from China are doing, but how can we make even better batteries and also support a European value chain? And one thing that we have to look at here is that there is a dilemma, let's say. So I guess you all know if you're working in this field that every battery needs conductive additives. And there is the state of the art, which is carbon black. And then there is a performance benchmark material that is used, which is single-walled carbon nanotubes. But the problem really is that carbon black is not so conductive, and you need quite high loadings to achieve a good conductivity in your electrodes. But it's cheap and it's abundant, but it's lacking performance. And on the other hand, you have the single-walled carbon nanotubes, which really excel in terms of electrical conductivity and making your electrode conductive. So you need only very little. But on the other hand, they are super expensive, and the basically 90% of the worldwide supply of this material is located in a single production site, and this is not inside the EU. So in between there, we have an opportunity. And I think that our eGraphene perfectly fits in this space. And I will tell you 6 facts about it and hope to spark your interest and see if we can work together in the future. So first of all, in terms of performance, our eGraphenes, as used in conductive additives in various electrodes, show really CNT level performance in terms of conductivity. So in numbers, they are around 50 times more conductive than carbon black. They are also affordable. So our process is quite efficient and also green. So it's mostly water based. And the E in eGraphene actually stands for electrochemical exfoliation. So it's an electrochemical process. And if you consider the costs in euros per kilowatt hour that you need to achieve a certain conductivity in your electrode, we can actually be 90% cheaper than single-walled carbon nanotubes. It's also easy to use. So what Maximilian said in the beginning is probably was true for his research, but it's a pity that you haven't known, or maybe didn't exist back then. But what we can actually offer is that with our process we can produce graphene that is intrinsically functionalized. So it is easy to process, and we can provide it in drop-in formulations, in dispersion or paste form, in various solvents from water to NMP, or usually whatever the customers require, without any surfactants. So we don't need any binders or surfactants or other additives to stabilize the graphene. And that really makes it very convenient and easy to use. What is also very special about eGraphenes is that in the future, because our production process has a very small footprint, we will be able to modularize and autonomize it. So the plan actually is that even at gigafactory scale, we will be able to produce the material on site or locally. So especially if you are considering that you want to ship around a dispersion or a paste with a few weight percent of actual solid material in them, you're shipping around a lot of solvents or water that on the one hand get accumulated in the place where they are used, and on the other hand, they also have to be transported. So this is something that really also makes our process unique, in the sense that it is possible to really integrate with the production, or at least produce it locally and significantly reduce supply chain risks and also logistic costs, and of course also emissions that are related to that. So in summary, basically, we can say that with eGraphene, we can achieve more energy density in the battery while producing less CO2 or less emissions. We can have safer batteries and lower supply chain risks, and all in all, achieve more performance for less euros per kilowatt hour. It's also interesting to know that beyond the conductive additives, which have been also proven from various customers and partners in various battery chemistries, like both NMC, LFP cathodes, but also various anode materials, graphene has also been proven as an interface material, for example, in solid state and lithium metal batteries, where it really improved cycling stability and energy density because it is really, really thin, and also as a separator material in redox flow batteries and fuel cells. So with that, I think I'm also finished with my 4 minutes, and I would like to thank you for your attention. If you are interested, if you have any application ideas, or you just want to learn more, please feel free to reach out. And yeah, for us, batteries are just the beginning. Thank you very much.
Thank you very much for this interesting overview. And yes, I have a couple of questions, but if there are questions from the audience, then please raise your hand. And but maybe before Dima can ask this question, I have just a really short one. As I understood it, you have the graphene in the solution, so you have like flakes. Could you maybe comment how big these flakes are and how many layers? Like, is it really monolayer graphene, or with which amount of layers are you working with?
So we are talking about a few layer graphene, which is essentially defined from different norms to be typically less than 5 layers, but could be up to 10 layers, I would say, depending also a little bit on the formulations. But yeah, to get a pure monolayer graphene, I think is really challenging if you start from a graphitic raw material and not build it from scratch, basically. But yeah, what we've seen is that also not really necessary to have a pure monolayer graphene for most applications. Yeah.
Thank you. Then Dima, your question.
Martin, thank you for presentation. Just a quick question. Do you also oxidize the graphene? So if I need graphene oxide, do you supply it to your clients or no?
So the electrochemical process that we're doing is in water, so that it can be tuned to introduce also oxidation to various degrees. Typically, we are not interested to oxidize it too much because obviously we want it to be very conductive. And but yeah, the process itself is very flexible in that regard. So if a higher degree of oxidation is needed or certain functional groups, then that's typically also feasible. So the process can be customized without changing the equipment. So it's really the recipe of the electrolyte that is like, yeah, influencing the quality of the material. Yeah.
Okay, thank you very much.
Sure.
Yeah, Simon, please continue.
Yeah, I less have a question than a remark. I recently visited Sixonia, and if you want to know more about this and also about the other battery expedition partners who are on board here, you're also free to check out the videos that are released soon because, yeah, also the visit at Sixonia was really inspiring to see how a startup like grows and defines its business case. So yeah, I just wanted to mention that. So yeah, also thank you for the insights that you provided.
Sure. Yeah, it was great having you for sure. Yeah.
Perfect.